So appreciate the opportunity um, from the Tri Societies to give me the opportunity to speak today to everyone about affordable phenomics. So my name is Valerio Hoyos-Villegas. I'm the dry bean breeder in the Department of Plant, Soil, and Microbial Sciences at Michigan State. And yeah, the title of my talk is Affordable Phenomics: Expanding Access to Enhancing Genetic Gain in Plant Breeding. So what does it mean from a sort of a philosophical question? What does it mean to a plant breeder? So we all, many of us are familiar with the breeding cycle. This is a way to simplify it, but generally speaking, it involves more or less three steps. There's three steps: intermate, evaluate, and select. And this can be sort of framed around the framework of the genetic gain equation, which is determined by selection accuracy and intensity of selection, additive genetic variance, and the time or the number of years per breeding cycle. So from that point of view, phenotyping is the structured and systematic measurement of a genotype or individual's traits. In other words, it's highly related with the evaluation phase of the plant breeding cycle. Okay, and an extension of that, we argue, or my definition, this in my own words, is that phenomics aims to collect and organize phen level information to better explain the underlying variation or uh, dissected trait variation. Okay, so therefore, in order to take this definition of a phen or an individual decomposed trait of interest, breeding programs require clear goals that to improve them, and clear goals require clear traits that can capture this information. So phenomics is revolutionizing this kind of paradigm. It's providing an avenue or an opportunity to increase accuracy and precision while reducing costs and manual labor in breeding programs. This comes with some benefits such as data rates, data collection rates, higher data density, higher precision over our standards. And there are some examples, as many of you may be aware, that, for example, RGB cameras and uncrewed area vehicles or systems can quickly capture this kinds of data, and they are increasingly becoming more and more highly multidimensional, um, enabling us to potentially better measure quantitatively inherited phenotypes, such as the combination of, say, line scanners or LiDAR and RGB or multispectral. So this is a word cloud generated from that work, and we can draw some conclusions from this. The first one is that affordable plant phenomics research is linked with breeding, genetics, and selection. So that's one statement. One of the primary tools the community views as affordable is uncrewed aerial vehicles, imaging and predicting modeling of this kind of data. So that's become a predominant research area of technology. The development of affordable phenomics tools, particularly the implementation of field-based tools, is directed at improving yield and grain or quality production, uh, uh, better quality grain production in the field. So this is most of these tools are oriented towards translating applicability in the field. And one of the areas of particular research is yield under drought or water use efficiency. Some of the concluding remarks. So a suite of sensors and platforms are a mechanism to overcome limitations. So there's a balance somewhere for breeders to adopt a tool, but there needs to be some careful thinking about what's the space, where is a happy medium between lower spatial resolution and spectral resolution, for example, or the pros and cons of a particular technology. Um, there's some unforeseen consequences of establishing low-cost pipelines versus end-to-end integrated solutions, which are usually commercial. Is the case, for example, of custom UAV pipeline developed inside versus a fully priced enterprise UAV pipeline. So this is a matter of the resources available. The efforts for in situ and predictive artificial intelligence are necessary to enable next generation phenotyping tools. In other words, since data analysis um, is a major bottleneck, so there perhaps is an opportunity for AI to alleviate some of these costs and also the delays that it causes, so that breeding programs can make timely decisions. There's great opportunity for collaboration between industry and academia in this space. It's already quite active. And there's one possibility is the development and validation of affordable phenotyping tools that can be iterated among the two spaces, the public breeding space and also the private phenomics industry. Um, so yes, innovative research and practical insights, and the best, as I said, the best product development will come from co-design based on the goals and outcomes that breeding programs aim. However, the breeder evaluations, as I said, are multidimensional, and the linearity of individual sensors can cause some loss of this multidimensionality or the complex decision-making process that goes into the selection process and breeding programs. And so this is something that eventually we'll need to understand and determine what is the let's say the practical cost or the unintended cost of of incorporating too many phenomics approaches, if that is the case. Uh, Finally, I'd like to acknowledge all of the people that worked in this effort, developing this review, and for all the interesting debate and discussions that took place throughout the development of this review.